Hi guys, so topic is adaptive Huffman coding update procedure. Okay, so basically in adaptive Huffman coding there is a three part. First is updating procedure, then second is encoding procedure, and third one is decoding procedure. So in today's lecture we will discuss about the updating procedure. Myself Kamal Sharma, working as assistant professor in the department of IT, KIT Group of Institution. So the content of today's video is overview. We just discuss about the adaptive Huffman coding and then we will discuss about the update procedure. So if we talk about the overview of adaptive Huffman coding, the first point is that the transmitter and the receiver does not know the statistics. Means the transmitter and receiver side does not know about the information uh, of the message. The second point is single node is used at the sender and receiver sides. And the third is nodes corresponding to the symbols transmitted will be added to the tree. And the tree is configured using an update procedure. Okay, as I already mentioned that the adaptive Huffman coding consists of three parts. The first one is tree update. The second part is encoding procedure and decoding procedure. So in today's video, we will discuss about encoding procedure. And as far as the encoding and decoding procedure is concerned, we will discuss in my next video. So overall, we can say that the adaptive Huffman coding procedure, neither transmitter or neither receiver knows anything about the statistics of the source sequence at the start of the transmission. So the tree at the both the transmitter and receiver consists of a single node that corresponds to the all the symbols all the symbols not yet transmitted and has a weight of 0. So basically in the adaptive Huffman coding, we use a node NYT that is called not yet transmitted node and always the weight of 0. Means the NYT node has always the weight 0. Weight 0. Okay. So this thing we have to kept in the mind that the NYT node is always the weight 0. Okay. Now come to the next slide. So in next slide we have to how to update the procedure. Before updating the procedure adaptive Huffman coding, we have to discuss about two parameters. The first one is weight of the each node and the second one is node number. If the weight of each node is concerned, there are two types of leaves. The first one is internal leaf or the internal leaf, and the second one is external leaf. Okay, so external or internal. External leaf or the external node may be represented by the symbol square, and the number of times a symbol encounter this leaf will be used. And the internal node or the internal leaf is represented by circle, always represented by the circle, and the sum of this internal node will be the weight of its offspring or weight of the child. Okay, the internal nodes, the weight of the internal node always be sum of their internal child. Suppose we have this internal child and these are the external, so the sum of these weight will be the final weight of this internal node. Okay, so the second parameter is node number. The node number basically use a formula that is 2m minus 1, where the m is the number of English alphabet, that is 26. So by calculating this formula, 2 into 26 minus 1, that is 51. So always the message any message, the maximum number is 51. Suppose we have a tree like this. Okay, so the node number starts from the root node, that is 51, then 50, 49, 48, and so on. So starting from the 51, from top to downward direction. Okay, so these two parameters we should keep in mind. First is weight of the each leaf. The weight of the each leaf means there will be the two type of leaf. First is external, or the second one is internal. External will be represented by the square and the internal nodes will be represented by the circle. Okay, the node number starts from always 51. Okay, node number will be started from 51, then 50, then 49, 48, 47, and so on, as per the length of the uh, message. Okay, now come to the update procedure. Suppose we have a message AARDBARK. Now this message we have to apply the update procedure of adaptive Huffman coding. Okay, now we have to update this message using adaptive Huffman coding. Okay, so I already mentioned that there is a node NYT having the weight 0 always. Okay, we should keep in mind the node NYT having weight 0 always. Okay, so initially we have a node NYT 51 having the node number is 51. Okay, this is node number. So initially we put a node NYT with weight 0 and having the node number 51. Now we have to encode this message AARDVARK. So the first symbol A will be encountered. So what happened? This NYT node creates a intermediate node, and this NYT nodes will connect to the left, and the new node will be connected to the right. Okay, let's take it this part. So this letter A will be connected to the right. Okay, this node NYT creates an intermediate node, and NYT itself joined to the left part, and the node and the symbol A will connect to the right. Okay, so the weight of the NYT always be 0, and the A, this letter A, this symbol A encountered first time, so the weight is 1. Okay, so the weight of intermediate node or the internode will be the sum of their child. So 0 plus 1 is 1. So this is 0 plus 1 is 1. This is 1. Okay, and the node number is start from 51, then 50, then 49. So this is the tree for letter A. Now the next letter is again A. So in this table we have already symbol A. I have already mentioned this tree. So what happened, as the symbol is already in the tree, so we just do it, we just increase the weight number by 1. Okay, so again we have a root node, and the left part is NYT node, the right part is already a. But what we have to do, we just increase the weight of A by 1. So 1 plus 1 is 2, so this is 2. So the weight of the root will be 0 plus 2. Okay, this is 0 and this is 2 equal to 2, and this will be the weight of the root node. Okay, so here we have AA. Okay, now come to the third letter, that is R. For R, what we have to do, we have already know that when a new letter is encountered, the node NYT, the node NYT will create an intermediate node and will join on the left hand side, and the new node will be joined on right hand side. Okay, this will be the new node. Now what happened, this letter R will join on right of the this node. So again this is the root node. Okay, now at the right hand side we have already the letter A, and this is NYT node. Then NYT creates a new node and connects in the left part, and this R will be joined on the right hand side. This R will be connected on the right hand side. So the inverting node weight is 0 and R is encountered first time, so the weight will be 1. So 0 plus 1 equals to 1, and again 1 plus 2 is 3. Okay, so the weight of the root is 3. Okay, now the node number is starts from 51, then 50, then 49, then 48, 47, and so on, as per the symbols encountered in the tree. Okay, now come to the next symbol, that is D. For the symbol D, what we have to do, we have to just follow the same process. There is a root, then the in right hand side we have already a symbol A having the weight 2. Okay, now this is again the node, intermediate node, then again this is the symbol R. Now here we have a node NYT, and this NYT creates a intermediate node and joins on left hand side NYT, and here on the right hand side the letter D will be joined with weight number, with weight value 1. Okay, so and the weight of NYT node is always 0, so 0 plus 1 will be 1, and 1 plus 1, 1 plus 1 is 2, and 2 plus 2 is 4. So the weight of the root node will be 4, and the node values will be 51, then 50, 49, 48, 47, then 46, 46, and so on. Okay, so now at this point we have make a tree. We have already made a tree for letter A, A, R, D. Okay, now come to the next letter, that is B. Now come to the letter B. Now we have a message A, A, R, D, B, A, R, K. Now we have to make a tree for letter B. Now again what we have to do, we just make a tree begin from the root node, just like here. Then we have a in right hand side we have a letter A. in left hand side we have a node, intermediate node, and after that the symbol R is just joined right hand side of this. Then intermediate, again there is an intermediate node on left hand side, then again letter D or symbol D is again joined at the right hand side, and here in previous slides here was the NYT node. So what we have to do, this NYT node will create an intermediate node and joins at the left hand side, and this letter will be joined at right hand side with weight 1, and the NYT node has weight 0. So 0 plus 1, 1, and then 1 plus 1, 1 plus 1 is 2, okay, and 2 plus 1 is 3, and 3 plus 2 is 5. So here all the intermediate nodes have assigned their weights and as well as assigned their node numbers. Now here we just look at this point. Here the node intermediate node 3 and 2 and node 2 and 1. Here we can easily see that the left node has the weight value 2 and right has the weight value 1. So left hand side the weight value is 2 and right hand side weight the value is 1. Okay. Similarly, in upper level the left hand side the node value has weight 3 and right has weight 2. Okay. But we should keep in mind that the left child, okay, left child, or you can say that the weight of the left child should be less than or equal to the weight of right child. Okay, weight of the right child. This condition should be maintained in overall question. Okay, we have to maintain this condition in overall the process. Means the weight of the left child should be equal or less than the right child. So if we consider in this pointer the left child, the weight of the left child is 1 and the weight of the right child is 1, so it's okay, means the weight of are similar. But in this case the left child has the weight 2 and the right child is weight 1, and in upper level also the weight of the left child is 3 and the weight of the right child is 2. So this is not fulfill the our condition. So what we have to do, we have to just share these two nodes as I already mentioned, display in the slide, and these nodes also. So we have to just swap these nodes. So after swapping we just have a this kind of graph. Now just check this graph or just check this tree. Here after swapping the node A lies at the left hand side and the node intermediate node having the weight 3 is putting on the right hand side. Again this right node having the child having the symbol R is on left hand side, and again this intermediate node this is on right hand side. So by swapping the overall tree we get the updated tree like this. Now just check the status of you can say the status of weight value. Now here the NYT node weight is 0 and the weight of this child is 1, so 0 plus 1 is 1, it's okay. Now here the letter D is the weight value is 1 and here intermediate node is 1, so 1 plus 1 is 2, it's okay. Now R having the weight 1 and 2, now 1 plus 2 is 3, okay. Now A having the weight 2, okay. Now we have to just check all these conditions whether the left child having weight is less or right, less or uh, more. So here the left child having the weight 2 and the right child is having the weight 3. So here the condition is fulfilled, and the condition is the weight of the left child should be less than or equal to the right child. So this is symbol A having the weight is 2 but less than the 3. So the condition is fulfilled, or you can say that the condition is satisfied. Similarly here the node R having the weight 1 and in right hand side we have the weight is 2. So again here the condition is satisfied. So in overall tree up to this level the condition of weight, that is the weight of left child is less than or equal to the right, is maintained. Okay. Now this is a tree after the shuffling. Now at this point we have built a tree for symbol A, okay, A R D V. Okay. Now the next symbol is A. Now the next symbol is A. For the next symbol A, we have just again update our tree. But as we in previous slide, the weight already mentioned is 2. The symbol A having the weight 2. Okay. Now this letter again encountered in the tree, but this letter encountered in tree at third time. So we just put the weight value is 3. Okay. So the 3 plus 3 is 6. Now the rest of the tree is same as the previous. Same as the previous. Because at this moment the letter A is encountered. So A is the left child of this root node having the weight value 2. Now this symbol is encountered third time. So therefore we just put the value 3 in place of 2. Okay. So 3 plus 3 is 6. So the updated value of root node is 6. Okay. Now come to the next symbol. The next symbol is R. This symbol R is encountered in the tree. Now what we have to do? This R is already in the tree. Now we have to do we just updating the value of R from 1 to 2. The rest of the trees will be same. So we just updating the weight of R from 1 to 2. Now here we have the weight value 2. Now 2 plus 2 is 4 and the 4 plus 4 is 7. Okay. Now at this moment we just updating our tree up to AAR DAAR. Now the last letter is K. For this letter K we have to update our tree. So at this moment we have to update our tree for letter K. Now at this moment we have letter A already encountered, R already encountered, D, V. Now at this moment we have to put this letter in our tree, letter K. So what happened in previous slide, the inviting node is here. So this inviting node creates an intermediate node and join on its left hand side, and letter K will be joined on right hand side with value 1. Okay, this inviting node is 0. So 0 plus 1 is 1. Okay, this one. Then V letter is encountered the first time, therefore we put the value 1. Okay, weight value 1. So 1 plus 1 is 2. Again 2 plus 1 is 3. Then 3 plus 2 is 5. 5 plus 3 8. Okay. Whenever we update our tree, we have to just check the condition whether the left child has the weight value less than or equal equal to the right child or not. Okay. Now at this moment we can easily see that the left intermediate node, this one having the weight value 2, is greater than the right child. Okay, but the condition is the weight of the left child should be less than or equal to the right child weight of the right child. Okay, but in this case the weight of the left child is greater than right child. So what we have to do, we have to just again do the same thing, and that is shuffling. So after shuffling, here we get the updated tree. So after shuffling we get the tree just like this is root node. Okay, now we have the left symbol is A having the weight value 3. Now again we have intermediate node, then we have again symbol R having the weight 2. Okay, now here we have to swap. The symbol D is joining on the right hand side, but in this case we just put it on the left hand side. This is the D. Okay, so A is already same, then 5 R, then G, okay, D, and this will be on alternative here. This is D and the weight value 1. Now again this part we will again this intermediate will be here, and this letter will be V on the right hand side. Again this is NYT, and this is letter K having the weight 1, then 0, 0 plus 1, 1. We having the weight value 1, 1 plus 1, 2. Then D have already weight value 1. So 1 plus 2 is 3, and 2 plus 3 is 5, 5 plus 3 is 8. Okay. Now this is our updated tree. Now just check the condition whether the left child have the left child have the weight value uh, less or equal to the right child or not. So this NYT, the weight value is 0 always. Now check this node, the weight is 1 and the right node the weight is 1. So equal. This condition satisfied. Here again the weight of the node T is 1 and the right hand side we have the weight value 2. So 1 is less than 2, it's okay. Now again 1 plus 2 is 3. So again the symbol R having the weight value 2 and it satisfies the condition that the left hand side is weight value is less than or equal to the right. So here is 2 and here is 3 on the right hand side. So this again the condition is satisfied. So this is a 5, weight value 5. Now here the letter A having the weight value 3, again 3 plus 5 is 8 and the condition is satisfied. Okay. Now see one thing, we have a string of symbols like A A R D B A R K. Okay, so this is our symbols A A R D B A R K. Now we can easily see that whatever we have a symbols, these all the symbols lie on the leaf nodes. Okay, this is A R D B A R. A encountered 3 times, so having the weight value 3. Okay, 3. Uh, So value 3. Now again R encountered 2 times. Again R, this R is on the leaf node having weight value 2 because R encountered 2 times. Now this letter D encountered 1 times. Okay. A D encountered 1 times. Then K encountered 1 times because the weight value is 1. Okay. Then V is also having the weight value 1 and encounter 1 time. So you can easily see that whatever we have the symbols in the string, all the symbols lies on the leaf node in a tree. Okay. So this is overall the updating procedure of adaptive Huffman tree. So in next video we will discuss about the adaptive Huffman uh, encoding procedure as well as decoding procedure. Okay. So thank you very much. Thank you.